Hello, good morning Year 10. Welcome to your physics lessons for this week. It's week 5. This is the first lesson of the week for the triple content, and as you can see on your screen we are looking at distance time graphs today. The key facts that need to be covered are on your screen. So before we get started, I would like you to look at today's starter. So pause the video and just have a go at doing those starter questions. Okay, so here are my answers. Everything there is fairly straightforward. The last question here is an interesting one. Sometimes you need to convert units. So if you were travelling at a speed of 1 kilometre per hour, if we imagine that that is our journey, and so the distance we've covered is 1 kilometre in an hour. Now if we've covered 1 kilometre, it means we have covered 1,000 metres, because there are 1,000 metres in a kilometre. And if we have been travelling for 1 hour, then we have been travelling for 3,600 seconds, which is 60 minutes times 60 seconds. So to convert 1 kilometre per hour into metres per second, we need to multiply by 1,000 and divide by 3,600, and that would give you an equivalent speed of 0.28 metres per second. Okay, on with today's lesson then, distance time graphs. So on your screen you can see a distance time graph. Now what is that actually showing us? Well, it's quite straightforward. It's telling us that after a time of 5 seconds, an object has travelled 10 metres from its starting point. After 10 seconds, it has travelled 20 metres from its starting point. So quite simply, a distance time graph is just showing us how far an object is from the place where it started during in a given period of time. Now last lesson we saw how to work out speed, and we put our equation in a triangle, so we know that speed went here, distance went here, and time went here. So then, as long as you know any two values, you can always work out the third one. So distance is speed times time. Speed, cover speed up, is distance divided by time, and if you want to work out time, cover it up, and it's distance divided by speed. So we know speed is equal to distance divided by time. So if we go back to our graph here, now how do we work out the speed of this object? So let's look at this first point here. Our speed is 10 metres divided by 5 seconds. After 5 seconds he's got 10 metres. So travelling at 2 metres per second. If we look at this other point here, after 10 seconds the object has got 20 metres from its starting point. So that's a distance of 20 divided by 10, still travelling at 2 metres per second. So a diagonal line like this Year 10 is simply telling us that an object is moving with a constant speed, and you can see that doesn't matter where on that line you measure, you still get a value of 2 metres per second. So a diagonal line means the object is moving at a constant speed, and in this case it's moving away from its starting point. A straight line like this, what do you think that tells us? Well, a straight line, a straight horizontal line, is telling us that the object is not moving. It doesn't matter how much time goes by, whether we've got 5 seconds, 10, 15, doesn't matter how long, the object remains 10 metres from its starting point. So it's not moving. Okay, what I would like you to do, Year 10, is just pause the video. You have got an object here with 4 different parts of a journey. Here A, that line is straight, then part C and part D. I'd like you to pause the video and just work out the speed at those different parts of the journey. If it's easier for you, I have just marked those different points against their times. So pause the video and just have a go at doing that. Okay, so this is what we should have found. For section A, the distance covered was 12 metres in 2 seconds, so that's a speed of 6 metres per second. At point B, the object was stationary here, and that happened for 2 seconds. And then part C is a little bit more tricky now because we're not starting from 0. So you can see the journey for part C started at 4 seconds and ended at 8 seconds. And the distance covered was from 12 metres away to 16 metres away. So a distance of 4 metres in 4 seconds, which was 1 metre per second. And then again for part D, the distance covered was 16 metres from 16 to 32, so that's a distance of 16 metres, and that journey occurred in 2 seconds, so the speed was 8 metres per second. So what do you notice about those different speeds, A, C and D? Well, it's quite straightforward. They are all of a different slope or a different gradient. So what's the gradient of that line telling us? Well, it's quite straightforward. The steeper the gradient, the faster the speed, and that's one of the key facts that you have been asked to learn for today's lesson. Okay, I've taken this diagram, this picture, straight out of the AQA textbook, and it's looking at long distance lorries that are fitted with tachographs, so that gives a very detailed description of the journey that a lorry will make. Now in this particular case you've got 3 lorries, X, Y and Z. What I would like you to do is pause the video here and just take some time to try and describe the distance time graphs for each of those 3 lorries. So pause the graph here, the video here, and have a go at doing that. Okay, so you should have found some of the following bits of information. Lorry X obviously went the fastest because it travelled the furthest distance in the same amount of time. They all covered the same amount of time, and Lorry X travelled further than Y or Z. Lorry Y travelled more slowly than X, and you can see that because the slope of this graph is less than the slope of this one, so it's not travelled quite so far, and in this case the actual value has been worked out at 24 metres per second. You might have worked out the value for X as well. Finally, Lorry Z moved the shortest distance, and it also spent a period of time when it was stopped as well. So it was stationary for about 500 seconds, and then it travelled at a much slower speed than the other 2 lorries because these slopes are less steep. Okay, finally for this section I would like you to pause the video and have a go at doing these questions. You might want to take a screenshot of the questions here and then have your video paused on this slide here where the graph is a little bit bigger. Okay, so let's just run through this, the answers here. Now you'll notice that the distance here is in kilometres and the time is in minutes, so you must always be wary of any units that you're working with year 10. Now you're asked how far did he walk altogether, so that's a distance of 8 kilometres. How far did he walk before he stopped to have a rest? Well, that was at this point here, so he had walked a distance of 6 kilometres. How long did he stop for? Well, he stopped from 15 minutes to 35 minutes, so in total he stopped for 20 minutes. At what time did he set off again? And that was at time 35 minutes. How long did he walk quickly for? Well, quickly is the steepest gradient, and this gradient is steeper than this one. So that was a time of 15 minutes. and the speed from A to B was 0.4 kilometers per minute, and if you took the trouble to convert that to meters per second, you should have got 6.6 meters per second. The speed from C to D was 0.2 kilometers per minute, or 3.3 meters per second. Now, you've then been asked to just add to the graph. So at D, he stopped for 5 minutes. So that should give you a straight line for 5 minutes. I really need to extend that a little bit more across there. So it shows that that's for 5 minutes. And then he walked home without stopping, and that took 20 minutes. So you should have recorded a straight line down here, finishing at 70 minutes from the starting point. Now, strictly speaking, year 10, we would describe this as a displacement graph, really, because we're talking about going back home. A straight line down here means he is returning to the point at which he started. Now, really, that we're talking about a displacement graph there, but for the content of your GCSE, we describe this still as a distance time graph, and a positive slope like this means you are moving away from your starting point. A negative slope means you are moving at a constant speed, returning to the point at which you have started. So just bear that in mind. Strictly speaking, that would be a displacement time graph, but usually it's described as distance from home, or distance from your starting point. Okay, now it's very important that you are able to draw gradients, that you're able to work out gradients. Now, some of you might already have done that from your maths lessons, but just in case you haven't, I think it would be worth just going over that here. So if you wanted to work out the gradient of a straight line, how do you do that? Well, you draw a triangle against the line that you're wanting to measure, so a line straight down and straight across, and then the gradient of that line is going to be the height of this triangle that you have created, divided by the base of that triangle. Now, you don't put a ruler up against it and just measure it, you actually use the values on the graph itself, and you use the values down here. So in this case, our gradient is going to be 120 minus 60, which will be that distance, divided by 8 minus 4, which would be that distance. And that will give you a gradient of 15 meters per second. Now, the reason that it's important you're able to do that, year 10, is because sometimes on a distance time graph you don't get a nice straight line, but you get a curve. Now, this is telling you that the object is accelerating, so it isn't travelling at a constant speed, instead it's getting quicker and quicker, and that's how we would draw that on a distance time graph. Now, it's really important that if you want to be able to measure the speed at any particular time, that you are able to understand how to draw a gradient, because this is what you do. You pick the time that you want, and then you draw a gradient or a tangent at that point. So when you draw a tangent, you're trying to get that straight line sort of the same distance one side of the curve as it is the other side of the curve, so that it's effectively perpendicular to that curve. And then you would draw your triangle and work out the gradient, and that would give you the speed at that particular point in time. Now, I've taken this example straight out of the textbook, so you can see here the object, which is the red line, is moving with this acceleration, and you are asked to find the speed at 12 seconds after it started moving. So you can see at 12 seconds at this point here, a tangent has been drawn to that point, and then a triangle drawn so that you can work out the gradient of that line. So I would like you to pause the video at the moment and just have a go at working out that gradient. Okay, so this is the same diagram here. Now you should find that you've got an answer of 11.8 meters per second. And how did we do that? Well, we need that height, which is going to be, I think, 140 minus 10. That gives us 130 meters, this distance here. And the time went from 18 seconds minus 7 seconds, which gave us a time of 11 seconds, and that gives you a speed of 11 meters per second. So at 12 seconds into the journey, at that point, the object was moving at 11.8 meters per second. Now I would usually give this to you as a worksheet year 10 in class. If you're able to take a screenshot of that and print it off, then I would like you to work out the speed of the train 5 seconds into its journey here, and also at 9 seconds into its journey. So if you're able to do that, then please print off a copy and have a go at drawing out the tangent and working out the gradient. If not, I have drawn those in for you, so I would like you to stop the video at this point and work out the speeds at 5 seconds and 9 seconds. Now you should have found that at 5 seconds the train was travelling at 0.6 meters per second, and at 9 seconds it was travelling at 1.8 meters per second. Okay, so to finish off year 10, I have put up 2 past questions, and I would like you to pause the video at each slide and have a go at doing these questions. This is the first one, and you can see that it actually specifies here, we've got a distance time graph, but you are told this is distance from home. So we're going away from home and we're going back towards home. So have a go at doing this question. And the mark scheme for that question is here. And then I have a second question for you, year 10. So please, this is in, I think, about 3 or 4 parts. So if you could just pause the video on each of these pages and have a go at doing this question. So part A is here. This is part B and C. And this is part D. And the mark scheme for that second question is here. So pause the video again and mark your answers. There shouldn't have been anything too taxing in each of those questions. Okay, year 10. So that's our lesson today on distance time graphs. You can see that we should have covered all of those different facts in this lesson. Distance time graph showing how far the object moves during each unit of time. Horizontal line means it's stationary. A straight line sloping upwards means it's moving at a constant speed away from the starting point, but a negative gradient means it's moving at a constant speed back towards its starting point. The gradient of the slope gives you the object's speed, and the steeper that is, it means it's travelling faster. And if you have an upward curve, it means the object is accelerating, and we have gone through how to find the instantaneous speed at any point of that journey by drawing a tangent and working out the gradient. Okay, I hope that lesson is clear to you. Year 10, as always, if you are struggling with anything, please email me and I will get back to you, but hopefully that was fairly straightforward. Okay, so enjoy the rest of your day and I will see you soon.